Hello, everyone. I think we can start the meeting because the first part of it gonna be mostly administrative, while the folks will join us. Welcome to the second day of the AI-DGGS workshop. This is an outreach event for the OGC AI-DGGS for disaster management pilot. My name is Sina Tagavikish, and I am a R&D project manager with OGC. Before we actually commence with today's activities, I would like to mention some administrative remarks. Again, similar to yesterday, I would suggest that all attendees mute their microphones. The discussions and panel sessions will be conducted in an open format. So please do not hesitate to join in into our discussions. The way it's going to happen is that our panelists, comprising of the participants, the sponsors, and the OGC staff, will signal their intent to speak by basically raising hand in teams to respond or basically define or set a new question. Uh, as for the general attendees, I would recommend that you submit the questions via the chat, so we will have the written version as well. And if your questions uh, is unclear, or if we actually do have time, we kindly ask you to unmute yourself, briefly introduce yourself, and pose your questions. Same goes for for the participants. Please just state the name. For example, this is Sina speaking, and then answer your question or set out your question. So, without further ado, let's delve in to the very short slides that I have. Um, just checking the chat. Okay. Yeah. So the OGC AI-DGGS team is actually as myself, which, as I mentioned before, I'm a project manager with OGC and the COSI sides of it, and Ingo Simones, which is our chief technological officer, that actually helped with the ideas behind this pilot. Uh, I would like to again thank our sponsors, which is NRCan, USGS, ESA, and CANES. And for the agenda today, we missed two presentations from yesterday. So gonna give those two participants 10 minutes each to present their results. That will give us some idea and maybe some even more context for today's discussions. Then we will have an overall summary of the first day that will provided by Stelius, by Hartis, and then we will have the first panel, which gonna discuss the flood risk discussion. That's gonna be moderated by Ryan Ahola from NRCan. And the second, then we will have a short break. Then we will have the second panel, which is the DGGS discussion. I will run that panel. And for the third and the final panel, which is going to be an interesting one as well, it's going to be about AI discussions. So Stelios Kontarinis will run the third panel, and that is basically it. So if we have somebody from Crim, maybe Francis, to share his slides,
Yes.
then we can start with that. Yes.
Is it visible for you?
Yes, perfect.
Perfect. My name is Francis Mio. I work at the Computer Research Institute of Montreal as a senior software developer. During this pilot, we work mainly on the server implementation of DGGS. Our objectives during the pilot were to evaluate the potential of DGGS as an alternative to the traditional GIS APIs, such as features, maps, coverage, and so on, and to integrate it along other such standards in our platform to evaluate the interoperability potential. We also evaluated the potential for AI integration to observe if the potentially AI could better leverage DGGS, as we observed in the previous pilots, the climate disaster resilience pilot, that we had a lot of challenges with AI that had trouble understanding coordinates and spatial relationships. So we're hoping that DGGS can help solve that. And we wanted also to integrate the API into our climate services platform. So making sure that their considerations for operational deployment are considered in our implementation. Our contributions were provided to various open source repositories. Firstly, there's the AI-DGGS API, where we collaborated with the University of Tartu and GeoLinks for providing a datetime-aware DGGS, that is a DGGS that can respond across space and time using different filtering strategies with temporal slicing and reporting the data of each zone across time. We also developed the alternate DGGS responses that were not supported by the API at the time that the pilot started, such as DGGS UBJSON with extra compression capabilities. We also added some filtering and query tooling so we can better retrieve specific zones of interest. We added some collection geodata metadata based on OGC API comment part 2 to make sure that we can have a better traceability of the originating data source of the data that was represented with DGGS. And we also added the Docker service implementation such that we can deploy it in our platform, which depends on this technology. We contributed to the DGGrid for Pi by improving the Python wrappers that were provided, adding support for DGGrid version 8, such that we can employ the fixes and optimizations that were provided in this version. Then we also work along the DGGrid itself by ensuring some capability and compatibility against the other DGGAL library that is very common in this domain. We observed with other participants that there was a lot of compatibility issues dealing with autholic and geodetic latitude values. So inevitably there was some shifts in zone IDs that were not represented in the right coordinates between different libraries. So we found some values to solve these. And we also address some issues regarding high resolution DGGS grid generation, where because of default values used by the library, there was incorrect generation of certain grids at very high resolution. Finally, we add the contribution to the birdhouse ecosystem, which is the infrastructure as code that we use for deploying to many Canadian organizations for climate science study. So this is integrated and deployed on our Hirondelle server for demonstration. During the testbed, we did a few during the pilots, we did a few explorations. First was the regarding the DGGRS registry and the metadata. We observed that across the various libraries that define DGRS, although they use the same terms, such as IZA7H or IGO7, they have slight discrepancies. So as mentioned previously, autholic and geodetic latitude are not considered the same way. There's some issues with H3 that doesn't or claims to be using certain datum definitions, but differs from what we can see in the observed results. So these discrepancies highlighted a need for an official OGC registry that properly describe each of the DGRS in detail and all of their parameterization so that each implementation can align together. There was also some issues with how the IDs of the specific zones are represented. For example, the IGO7 and IZA7H plus the Z7 indexing system that represent essentially the same zones, but with different IDs to identify the zones. So these needs to be differentiated and probably cross-reference between each other to provide some information about their compatibility. We explored also the DGGS daytime aware response. As mentioned previously, we have some climate portal integration where temporal is absolutely necessary. So we wanted to ensure that DGS is not considered just as a spatial zone index, but also allows all the relevant spatial slicing and querying, temporal slicing and querying. So we added these functionalities, but we observe a lot of issues where sometimes you have holes in data sets, and representing these holes might not be very efficient when there's really a lot of holes and just a few values in sporadic locations. So evaluating the sparsity of the DGGS responses and how alternative representations could be used to better leverage efficient data transfer. These were explored during the test, but during the pilot. We also faced some aggregation challenges between some collections that use temporal information and others that don't have it. So how to make sure to aggregate this in a coherent fashion so we can have a response that includes both collections with their different temporal consideration. We also explored the storage backend. So one of the common approach that seems to be used is to employ the DGGS UB-JSON for high compression, but for the same reason as the various sparsity of data that we observe, we started exploring the Parquet, which is commonly used in stack catalogs, for instance, and we found a few optimization that can leverage the indexing that Parquet already use to represent directly the DGS zone IDs, saving a lot of storage space. And since only the relevant zones of interest are stored in the database, there's really a great compression there by not storing empty zones. So we explored how to potentially leverage that Parquet representation for performing more efficient data search with specific zone IDs, and also because of the Parquet representation itself being a tabular definition, we can see some great potential for AI use that basically don't have to worry about the coordinates interpretation as you just deal with a single ID. It's easier to do pattern recognition, and the IDs themselves are already encoded in a ER key, so it's easy to let the model look at the values of the IDs themselves and figure out some kind of spatial relationship just by the way they are encoded themselves. Lastly, we did an exploration for the DigiGal and DigiGrid comparison. So as I mentioned a few times before, there was a few discrepancies. This is illustrated in the figure, so we can see that the pink zone is the result that we would obtain from DigiGrid normally if we didn't tweak the result, but the expected one is the yellow one just under. So there's an offset which create some issues if we don't correct these, since the DGS responses omit entirely the definition of a coordinate, and we rely on the libraries to reverse engineer the coordinates corresponding to the zones. So by the exploration that we did with these libraries, we were able to figure out the relevant parameterization so that clipping of zones and the generation of the grid is aligned between the different libraries. The collections that we produce are essentially including the temporal based on the stack RCM RD data provided by NRCan EU-DMS has been quantized to the IGO7 DGRS representation, and it deals with the various O's such as presented on the left figure. So you can see that the satellite pass went partially over the zone of interest, so it deals with the missing data values and all these concerns across space and time. And there's the Canada population dataset that we encoded with H3, also with sparse representation, so represented on the right image with resolution 10, I believe, or 8, something like that. This is it for my presentation. If you have any question, do not hesitate or look at the repositories. We're happy to receive contributions and collaboration with different partners. Thank you.
Thank you, Francis. If you do have questions, please put them in the chat and we will respond. I mean, Francis will respond back, but we will have lots of time for discussion, hopefully today. So let's move to the second presentation for today, which is the last presentation for the participant, and that's Nicolas from CS Group France.
Hello, can you hear me?
Yes, we can hear you and we can see it. There's
Yes.
the slides.
Perfectly. Okay, fine. Thank you, Sina. I'm Nicolas Villard. I'm working for CS Group, which is an intermediate company, a medium-sized company located in Toulouse. We are a company specialized in geospatial activities for different domains, mainly for space, defense. In Toulouse, we have acquired strong skills in hydrology domain. So we have many projects for CNES, for European Space Agency, and the French Ministry of Environment about hydrology. And here are some of the customers we are working with in various government space agencies. We recently joined the OGC this year, last year. And we are quite new to OGC at CS Group, but we made in the past we led different projects related to DGGS before standardization by the OGC, and following carefully all the work led by OGC during test beds. And so we developed a few prototypes. Here is one example of what we did 2 years ago for ESA, a demonstrator capable of exploring data cubes based on Copernicus Sentinel data and exploring time series, displaying the raster data and dig into radiometric indices. More recently, we worked with STAC and used DGGS to display the result in a very user-friendly way, to aggregate the result on different collections and catalogs. So I will pass quickly on the objective of this pilot, which was the main was to how to get the tools we have in AI and the large language models to explore collections and data sets available and made online by the partners on this pilot. and identify any missing part in the DGGS specification. So we wanted to develop a client as generic as possible, and which is able to connect to and tie with as many partners as possible. So this point illustrates how we connect to different endpoints and with different DGGS collections and reference systems. On this slide, I will present very quickly as well the high-level architecture. Our client is mainly developed in two independent components. The first one is the client itself, which is using long chain for the orchestration, and which contains all the intelligence, if I can say, of the client, with different prompts and at least a series of tools which are made available for the agent. So it can execute remote code, but also local code and business logic if we want to make some computation based on the data which is retrieved by the client and so on. And it contains also as well the user interface and for the chatbot and the map. The second component is MCP server we developed, which really does the queries and the requests to the API providers. And we delegated to this MCP server all the queries and interactions with the DGGS APIs. And so the idea is that the agent is able to select the right tool to do the right operation. A few words about the different challenges, because we have a lot of collections made available by the partners with different DGGRS. So some are supporting more the DGGRS than other. It can be tricky to handle different collections at the same time. How to integrate the DGGS API with the chatbot was also a challenge, as well as defining indicators and computations based on the data we retrieve from different endpoints. That's some features where we spend some time, and how to connect to external services when needed. Maybe for geolocation, we used external services by the agent to locate cities and a point of interest. We get some challenges in the API retrieval itself, because the current specification is picking data, is allowing to retrieve data from a single cell ID, and based on the parent-children relationship. So we made some interesting discussions about that, and Geomatis proposed a new endpoint for this. We had to deal with different DGGRS, and that was not an easy task at the beginning of the project, because we were depending on different libraries. And finally, we adopted DGGAL from Itere, which was really a game changer, and which simplified a lot our work of integration for visualization. At the beginning of the project, we were using H3 for the same reason, as it is very common and well supported by different visualization toolkits. And we highlighted some issues with it, as well as we discussed yesterday. And one of the biggest challenge was to create a simple, user-friendly interface to ask questions to the different data available, and which is very responsive and fast, because we are working with vectorized data and not working with raster. So we need efficient and fast visualization toolkits. Here is a very quick demo of the demonstrator. You can see it's split in two. You have a list of instructions you can send to the demonstrator, and a map viewer to display the results. So I prepared yesterday a simplified video for because we were short of time. The idea is to show you how we can create complex tasks using a single prompt instead of decomposing a step-by-step process. So what I'm asking the agent is to look at the different providers and different collections available and find information about floods, about population, and to create a simple indicator based on the two first layers. It seems frozen. Okay. So when we launch the process, the agent determines itself which tools to use. So it starts exploring the different collections available and to geolocate the area of interest. So I asked to analyze on the Winnipeg area. So so the agent is geolocating Winnipeg and then list collection. Find relevant collections regarding population and flood, and then it dig into the collection details and check all the fields available and in which DGGRs they are available. And once he finished, so is able to create a map with different all the layers I asked. And what's interesting is it is able to explain the process and the iteration. So we can see the three data sets I requested and how he managed to get them, and explain the mapped field he used from different collections. So that's two collections from Examine. One was pretty obvious, flood cause was interesting. It matched what we requested. For the population, it was not as easy because the field name was grayscale, which is not very straightforward to understand. But he managed to create a link and use it to map the population. So then he created the flood rate, a very simple flood risk index, combining the two layers. That's just a simple example to show you the possibilities, because the agent is able to self-explore and create his own steps, and following a simple scenario written by the user. Okay. So in the next steps, we have highlighted the need to define a standard way to write complex scenario using single prompts, or to pre-compute some scenarios. And we faced some issues related to the metadata as well, which were not very accurate in some cases. And so the agent couldn't determine very well, only by the names, which one to use. So that's maybe a point we can dig further. And we found also that these technologies could also be suitable for other API, OGC API standards, such as OGC features, record, and process. So DGGS could become a universal way to query raster and vector data, but this is quite promising. But today, up to today, of course, many software and libraries have to be adapted, and the DGGS specifications should be implemented. Yes, that's a new paradigm, and but very, very promising. And that's it for my presentation. Don't hesitate if you have any question.
Thank you, Nicola, for this presentations. And yeah, so with this, we are done with the presentations from the other day. But now we will have Stelios presenting the overall outcomes of the pilot, just to warm up the discussions that will follow up. So I'll ask Stelios to start presenting. And yes, Stelios, we cannot hear you if you're speaking.
Sorry, I didn't speak. Can you hear me?
Okay, all right. Yes, we can hear you now.
All right, thank you. Hello, everybody. I'll try to wrap up the first day and provide some conclusions on what we achieved through the pilot, findings, technical outcomes, and some future outlook. Yesterday, I showed you this slide. It's a generic slide. I will go a bit more in detail here. What are the core technical outcomes? We demonstrated successfully interoperability between 4 API DGGS clients and 6 DGGS servers for several different DGGRSs, validating the standard in an operational environment. We tested thoroughly the discrete global grid abstraction library across multiple runtimes, providing the portability of OGC grid math across diverse software ecosystems. We evaluated the MCP, the Model Context Protocol, in enabling AI agents to autonomously discover and interface federated DGGS endpoints. We found performance issues on the use of, and we used the compressed DGGS UB-JSON FG blobs and Parquet to manage high-velocity data holes without banding penalties. And we found several quantifications issues and defined proposals for quantization extensions to standardize how data is aggregated, like mean, max, average per grid, through the API, and somehow the agent to understand what are the possibilities of asking such questions, ensuring scientific ground truth for disaster modeling. Let's go through the servers. We saw today CREAM. They leveraged their own Python-based PY DGGS API. I will go very fast because Sina told me that. Acre, we saw them yesterday. They used the Gnosis map server and the digital library acted as the technical backbone for grid geometry. The Geo Insight, they brought a modern Rust-based implementation to the pilot, focused on speed and cloud-native efficiency. GeoLinks, they are core developers of the PY DGGS API and underlying DGG RID4PY tools. They provided foundational tooling that other participants relied upon. Geomatis, the Java-based Examine server, tackle the complexity of multidimensional data, space, time, and height. Safe software using the FME data visualization demonstrated that don't always need to write code to save DGGS. Regarding the AI clients, Compusol focused on the chat to map reality. They developed a robust React-based chatbot client that served as the primary test bed for interoperability. CS Group moving beyond simple chatbots, focused on agentic AI workflows that treated the AI not just a text generator, but as an analyst capable of planning tasks. Hartis generated new insight that developed the Flood Impact Index, a sophisticated model that fused a satellite flood extents, weather predictions, and terrain data into a single score per grid cell. And finally, TerraFrame brought context to the grid by integrating DGGS with spatial knowledge graphs, while others look at where the water was. TerraFrame looked at what was affected. And finally, our architect focused 4113 engineering focused on packaging data for human decision making that defined the common operating picture, a machine-readable JSON schema, extending OWS context that serves as the brain of the operation. We tried to summarize what were the main issues that we found implementing the DGGS standard, and we used the word frictions. The objective was to reconcile the theoretical standard with the requirements of real-world software emergency response, and somehow we summarize the findings in 4 items. I will go through each one of them. One friction is the geometric alignment between the widely used systems like H3, where they were built on orthogonal spherical models, and we tried to map them on the WGS 84 ellipsoidal systems. It was an integration fix. Then we had another performance fix where high-resolution satellite data is often sparse and contain large empty gaps where sensors don't pass. And we utilized optimized data encodings. The stacking paradox, it's an accuracy fix that Jerome talked about it yesterday, and found some topological tools to account for the actual 30 overlapping subzones on Aperture 7 grids. And finally, we tested a lot the DGGAL library. This is my 2 cents for Jerome. I hope you like this logo, Jerome. I think I didn't find any while I was looking at too. Regarding AI, the key word was orchestration. How will we achieve the necessary orchestration in order the AI agents somehow to communicate with the servers providing the DGGS data? One major issue is that some LLMs usually do not inherently understand the computational cost of geospatial requests. For example, if you're asking for a very high resolution, you may ask for many data and the system will crash. So you need someone that somehow will take the decision that, okay, I cannot provide this question and please refine the resolution. So that's why we used the MC protocol as an intermediate orchestration layer. Another main issue is how we achieve descriptive grounding. LLMs have the ability to reply to any question that you will make them, even if they don't answer where to get the details. So we need to guardrail them and tell them where exactly that you will need to find the information and don't make information. We need APIs that somehow will provide all the necessary metadata that AI agents will need in order to decide on what will be the plan for answering or providing the sophisticated answers back to the user. So there is a need for machine-ready APIs there. We tested the semantic reasoning, improving the MCP with special knowledge graphs in order to know relationship between objects. That is a major advantage that we can dig further into it. And what we came as an outcome in many discussions is that generic LLMs may be not the most efficient in order to handle such situations, and we may need small domain-specific models that will be trained on specific domain and natural phenomena in order to provide ground truth and solutions to specific problems for disaster management. Regarding the future work, mainly regards to standardization related to OGC, the vision is to evolve the standards from passive data retrieval protocols into active frameworks for geospatial reasoning. And if we use AI technology to move beyond chatbots to geospatial analysts. And the strategic goal is to ensure that AI agents request analysis-ready data receive an identical mathematical response from any server in a federated network, regardless of the vendor. That was not the issue in every case that we examined during the project, so soon we need to work on that. A core pillars for that is geospatial grounding, ensuring the AI logic is anchored in physical reality, multi-grid interoperability, where to enable seamless data fusion across different DGGS structures, and provenance-backed mapping, creating a traceable chain of evidence from the source data to the AI conclusion. We have a series of 6 roadmap actions that, as OGC, could be the next steps towards the further improvement of the standard and related activities. One could be to have an authoritative DGS registry. As now there's various DGRSs, but there are not a certain a specific registry where the, developers can see what is the purpose of each system and why to use it. There was a guide that we tried to make on the DGS selection. I think I saw a slide from Sina, and we can talk more about that. Another action it can be improving the APIs in order to have easier for the clients to retrieve data, extend somehow the zone query. That was a proposal by General Matisse and CS Group, in order to allow the agents to query via natural geography. And one solution can be leveraged further the SQL2 filters. We propose to have an OGC best practice for H3 in order to solve this issue with a spherical, othelic, and ellipsoidal WGS systems, and publish a canonical OGC definition for H3 that explicitly resolves the othelic and ellipsoidal conflict. Work more on the temporary grading parameters of the DGGS. There were many actions done, adding daytime parameters, but we may need to work more on the standard and providing specific temporal resolution parameters. And one other activity we propose is to work more on the common operating picture, so to provide a specific guidance on how the clients can work with a framework in order to communicate with the servers, integrating the IPT framework, which is identity, provenance, and trust. And a very important one is to work on advanced analytic extensions and moving the DGS beyond the storage format to a computational environment, and have capabilities like custom aggregations and derived fields, cross-collection queries, and direct zone statistics. There are some technical references. There are also on the website that are discussions on the OGC API coverages, I think, working group there. All this information is summed up on, or is provided in more details in the engineering report, which provides the formal record for this pilot. It details the architectural consensus reached to bridge the gap between AI reasoning and the rigid requirements of high-resolution geospatial grids. I want to thank all the people that provided information for this report, which is listed here. That's all from me. Thank you.
Thank you, Stelios. That was an amazing summary. All right. Any questions for the participants from yesterday or for what Stelios presented? Please put them in the chat, and we can, I don't see anything in the chat, so we can continue maybe with the first panel. So I would ask Ryan Ahola to unmute himself and maybe to start the discussion for the disaster response part of this basically the use case of the pilot? Ryan?
Yeah, no, thanks, Tina. So as Tina mentioned, I think at the start of this meeting, so we're going to have a series of panel discussions. It's not so much of a formal panel discussion. We'll have a fairly open conversation amongst the various pilot participants. So we're going to start with more of the scenario part of the pilot, which focused on flooding, but I think we can expand that into other types of disasters as well, since a lot of what came out of the pilot is widely applicable across different types of emergencies. And then we'll get into more focused conversations on DGGS itself, so some of the commentary on that, and then on specifics related to the AI elements of it. So I think what we're interested in getting out of all of these pilots is to have more of an understanding of the participants' experiences within the work itself that was undertaken as part of this specific project, and then getting into discussion of
we don't
future works.
speak too quickly.
Oh, sorry, I can slow down. Yeah, so yeah, so what we're hoping to do as part of this panel session is to get perspectives from the participants on their work within the context of the project, and then have suggestions and recommendations for next steps for future work. So we'll start with the flooding side, and what I would suggest is, for participants who want to answer the questions, I guess raise your hand and we'll direct you to, or we'll go to you. And then as for everyone else, if you do have a question, please post it in the chat, and I'm sure we could have you ask the question verbally as well if you're interested. So first question for flood risk. So what I would ask is, based on your experiences in the pilot, can you comment on the value of DGGS for flooding, like flood risk, other flood applications? Are there particular applications in the context of flood risk that you think that DGGS is better suited for, or are there approaches, or are there specific applications where other approaches may be more preferred? Oh, yep, someone's raised their hand, so please go ahead.
Yes, thank you. It's Lucas from Hartis. My name is in Greek. Apologies for that. I joined from my institutional account. I think something really important was how we can easily and fast query with spatiotemporal data. And while we were testing, for example, the ERA5 datasets with multiple and many different parameters like snow melt, precipitation, etc., it was quite easy and fast to aggregate data temporally speaking, to query different resolutions, resolution 5, 8, 9, or maybe start an analysis from resolution 5, and in areas of high flood risk, let's say, then to have a second or a third analysis at the resolution 8, 9, or 10. That was really, let's say, an added value of the DGGS usage. And of course, we should always remember how we can play, let's say, in quotes, with the different DGGS systems. I mean, with some quite easy to use parameterization, we may change the system from H3 to real heat peaks, or IZEA 3.8 or IZEA 3.8, etc. So I think this was something really interesting and important. Thank you.
Great, thank you. Yes, anyone else? I posted the question I asked in the chat, so it's if you could read it if that's helpful. Yeah, and again, if there are other, I would encourage everyone, if you do have other your own questions related to flood risk, if you're an attendee or a participant, please go ahead and ask, so we can have a conversation.
Yeah, Dean Hintz here from SAFE. Just to comment quickly on question 1. Yeah, I think DGGS is very valuable for flood risk, particularly when you're looking at if building a flood risk index and then applying it to a range of different domains for different types of impacts. So I think there's a lot of good potential there. I think some of the challenges might come in to when you're looking at higher resolution data, or maybe automating, evaluating a whole time series. I think some of the tooling for that, and also integrating more high resolution, because given the different types of grids, getting everything aligned, I think that we're still sort of working on some of the tooling on that. I would be curious for if what the comments might be from some of the client participants on dealing with higher resolution. So I think when you're dealing more with flood risk index, you have sort of like a probability surface of flood risk. I think it's very useful for that. If you're trying to actually predict, doing hydraulic modeling and then predict where the flood's going to go, it might be a bit harder using DGGS for that, but that's just my general impression.
Thanks, Dean. Any other comments on this question, or maybe related to? Yes, sorry. Go ahead, Nathan. Yeah, you're on mute, Nathan. Sorry.
Thank you. Sorry about that. So just prior to starting this project, we were working with our main sponsor on this work, Army Corps of Engineers, and they had a number. They had expressed a data management challenge to us, which is, as they've modeled multiple inundation scenarios for, let's say, a particular body of water, each inundation scenario would carry with it a different geometry, depending on the level. And they said just managing all that was incredibly difficult. And so we actually presented to them DGGS and said, well, this seems like this would be a much would be a viable alternative because of the dynamic nature of the API itself, so that you could actually query the API. If you were to take all these inundation scenarios and quantize them into zones, then that you'd have a central point for getting information on these different inundation levels. And they were really excited about that. So in that scenario, it seems to really simplify the data management piece, if that makes sense.
No, I think so. Yeah, I think there are a lot of good in your work and others in this pilot as well, demonstrating the value of DGGS for simplifying data integration and having things being consistently presented at a location. Yes, go ahead again.
I'm trying to lower my hand, and I'm done.
It's me again, Lucas. Just to add to what Nathan mentioned, it was quite impressive how we managed to reduce the number of queries on the servers. It's, let's say, more technical, but having the opportunity to query at the resolution 3 or 4, let's say, but at the same time using this, parent zone parameterization, you may ask for multiple data sets at resolution 8, 9, or 10 without hitting the server, let's say, or overloading the server. That was really, really helpful. We tested that for the past 2 months. It helped us a lot to reduce, the running times for the models, because it's a vast amount of data, topographical ones, hydrological ones, environmental ones, socio-economical ones. So with just a few queries, even in different servers, we could have a big volume of data without overloading the servers.
Okay, no, excellent. Thanks.
Thank you.
Yeah, go ahead, Peter.
Can you hear me?
Yep.
Okay, great. Yeah, sorry, I've been sitting on the sidelines watching, and I have a question for the people who set up DGGS servers. It seems that DGGS is well suited when the data set is constrained, like it would be in an emergency scenario where you're only concerned about an area. But it sounds like you sort of have to pre-compute the cells. And how would that scale out to something like, I have the Sentinel archive and I want to build a DGGS grid on top of it? Does that actually work? Or I'm not sure if I completely get how that would be set up as a DGGS server. Does that question make sense?
Yeah, I think Jerome was first to respond.
Hi, Peter. Yeah, so about the question regarding Sentinel-2, so we've sort of implemented that, and also I think also related to Dean's comments about whether DGGS is suitable at a high scale. So the idea is if your backing store somehow has a concept of multi-resolution, and that might be cogs with overviews, which you have some of that to some extent with the Sentinel-2 data. Except depending on the source product, it might not go all the way to one-by-one overviews. And also the fact that it's kind of pre-split into multiple granules kind of adds some challenges. But the idea is if you have the data at multiple resolution already, when you try to map this to DGGS, you can actually do it at runtime because you don't have to go to the full data. So if you already have some kind of overviews, then you can resample and use basically the next closest resolution so that you don't really lose precision when you do the resampling. So
okay,
that's kind of
you don't
how
have
it
to,
scales.
right? So you don't really have to pre-compute these things and store them somewhere, right? Is what I'm getting at.
I mean, what you need to do multi-resolution is you need some kind of pre-computed overview somehow, right?
Yes.
It can be, it could
Okay.
be it doesn't need to be in exactly the same DGGRS, although that is what will give you the fastest response. But if you
Right.
have something in any kind of DGGRS-like thing, and that includes cogs and geo packages that kind of have these overviews or 2D tile matrix sets or a WMTS service, anything like this with multiple resolution, then you can leverage that and use the next best resolution so that you don't really lose anything when you resample because you're resampling from more precise, more finer data going to the coarser one, so you don't use too much, and then you can achieve scale and performance if you as long as you have that. But it's a little bit difficult with the Sentinel-2 in particular because of how it's kind of already pre-split into different granules. And you need because there's so many of these small granules and you don't really have like big overviews because the biggest pieces are quite small, so that's a bit challenging, but it's kind of doable.
Okay, thanks. I think that answered my question, Jerome. Thank you.
Thank you.
If I could figure out how to get my hand down, I would, but I can't.
It's okay. I think I can lower people's hands. That's fine.
Right.
I saw
Thank you.
Johan had his hand up briefly, so I don't know, Johan, if you wanted to comment as well on that. But
yes, but actually, Jerome said nearly the same thing, so I won't add anything else.
Okay, no problem. All right, maybe we can move on to a different question. So one of the other questions I had. Oh, sorry. There's yeah, there is a question in the chat that's posted. Yeah, so this is more about the integration of what the participants' thoughts are on the integration of AI with DGGS to support flood-proof needs. So what worked well and what needs to be improved. So maybe we can move the discussion to focus a little bit more on the AI side in the context of flood risk. So does anyone have any thoughts on their perspectives with the use of AI in the pilot and combining it with DGGS? Yeah, go ahead, Dean.
Again, I'll defer to the folks that worked on the clients who can kind of perhaps provide more precise examples. But my general experience with the way we were serving up DGGS and working with folks like Terraframe and also Hardis is that I think DGGS did a very good job of providing geospatial context for AI. So in the absence of DGGS, you would have to, if you just had location names, you might do geocoding and reverse geocoding if you're running from an LLM. So you have to sort of ask the question, well, what would we do if we don't use DGGS? And so some of these geocoding methods are not going to be very precise. So basically, DGGS just gives the AI a language for asking spatial temporal questions about, well, where's the flood risk, in this region or in this time frame. So I think that that was demonstrated very clearly in the pilot. And then I guess was the other part of the question. Sort of like how bidirectional it is. I suppose I feel like we're only scratching the surface is how do you do the AI orchestration? So, you can make DGGS, you can maybe wrap it up in MCP and make it available to AI agents. But then how do you do sort of cascading? So ask for flood risk, then ask for different domain information about the impact of that flood on populations, on infrastructure. So how you kind of do that whole cascading logic with AI, that's, at least for me, it's a bit fuzzier. And I think some of the questions around that are what sort of metadata do we publish alongside the DGGS services so that they are more easily discoverable by AI. So I'm answering your question with a question. Anyway, that's my 2 cents.
Yeah, no, thanks. I think that's great to consider for future work. Stelios.
Yeah. When we initially tested the client that we prepared, asking questions about getting data and analyze them, the system seems to bringing H3 zones easily and providing answers, meaning that it could understand what is a DGGS system, but the identifiers were not at the same place that we're asking about, meaning that we had hallucinations. I'm saying that the LLM understood what is DGGS and it made up information. So we put a lot of effort in guardrail the LLM in order to get the authoritative data. To go closer to the question is that we found it that it was helpful, easy for us in order to have data from different sources in one cell and make calculations on a specific cell. That was really easy. And this can be a road to further complex analysis, I think, if you have all the necessary data to present to a model and have them in a space that you can have a low resolution and a high resolution at the same time doing granular analysis. I think this is very helpful, and that opens a road for further achievements on geospatial reasoning. I think this is my impression, at least.
Yeah, no, absolutely. No, thanks, Stelios. I think Michael is next.
Yeah, thank you. Michael from GeoInsight here. I'm trying to answer that question, what the benefits for AI and DGS are, and if they're mutually. I see 2 ways in which AI can interact with DGGS. The one is obviously, and that was most explored in this pilot, through an LLM. What I see where the real benefits are is when you use and write an AI model that interacts with these zones and takes these zones as tokens. It happens exactly the same when you train a model on text. The text has to be tokenized. It has to become ones and zeros in a sense. And a DGGS gives you exactly that. It was actually a request from the GeoAI domain working group. They were looking for ways to sort of tokenize space. They were actually saying exactly these words, spatial tokenization. And DGGS delivers you that. The data may be sparse, and you may only have a signal in a few of your zones, But that is also information. You know that the zones in between don't have something. And if you train an AI model, I did this way back in a research paper, it actually is a very digestible format. You have all your zones with all the values and parameters that you collected from your data sets. And then you label some of these zones with the phenomenon that you want to classify. And it is a super effective and efficient way to do this. And it goes a bit to that point of also, do you need to pre-transform your data? And I would say, yes, if you want to run an AI model in that idea that I just laid out, then I would say you don't do this on-the-fly transformation. But that's a bit of a different angle to DGGS than what was explored in this pilot. I hope that helps as an answer. Thank you.
No, thank you. Yeah, I think it definitely does. And Justin was next.
Yeah, just quickly, I think from our point of view, kind of what worked well and what needs to be improved from the AI standpoint. Like, I think one of the big benefits that the AI, at least LLMs, gave us was more of an accessibility thing. I don't think a lot of people are like super knowledgeable about DGGS and the new OGC API. So having the ability to make natural language questions to anything and like sort of just encapsulate that and get somewhat of meaningful responses from it was a big benefit. I mean, AI does that for a lot of domains, but it's certainly a benefit for this. I think, that's kind of easing the sort of input into DGGS. I think what needs to be improved and what people have talked about is kind of getting output from DGGS and kind of doing further down analytics from it with AI. Yeah, I mean, I think a lot of other clients, not just Terraframe, we ended up putting like orchestration layers about to handle the response from DGGS as opposed to just like directly giving output back to some sort of LLM model to like let it summarize data. That didn't work very well. And so I think that is kind of the next area of improvement.
Okay. No, thanks, Justin. Yeah, I'm sorry. Did you want to say something else?
Nope. Okay. That's all I got.
All right. No, thank you. Yeah, I think your comments are spot on. Yeah, because certainly for the emergency management community, I think like the generative AI piece is going to be really helpful for better using geospatial data in general, but particular DGGS. Yeah, so maybe that is a next future area of work is to figure out how those interactions better happen, and to improve the analysis component that you were talking about. Yeah, lastly, I think Jerome.
Yeah, so thanks. So like, as I put in the chat, I think something that we didn't really explore in this pilot, and maybe somewhat radically different, but not so different to what everyone is currently already doing in the geospatial, maybe more with regular tiles, which are rectilinear. The idea of the subzones, which is kind of the core of things with the DGGS API and the zone data responses, is really intended for getting like millions of zone values back. So it's really for like a high throughput analysis scenario. So which is kind of why the other endpoint was proposed, the slash zones for the kind of thing that we did in the pilot, where we basically just asked the server for a few values where maybe the server already summarized things. But it would be interesting to explore kind of this zone data retrieval with the subzones. And doing using an LLM in a similar way that the image LLM handle things, where basically when the LLM looks at the data, it's looking at a particular parent zone specifically, and then it's kind of used as this attention mechanism, which is kind of the big boom behind the big thing behind the AI boom, where it basically relates all of the values inside the parent zone to make sense of what you see inside this one big data packet. and then you can further combine this with the other parent zones around, but kind of making sense of what is inside this big parent zone with all of the millions or thousands of millions of values in here, and then further aggregate this with the zones around. So I think that would be the very interesting approach, which is more similar with how like image analysis is done, but applied to any kind of DGGRS, including like the hexagonal, like the IVIA 7H and all of these. And that's kind of what one of the things that the subzone concept of the data retrieval would make possible. So I think that would be very interesting to explore in the future activity.
No, absolutely. Yeah, I think for emergency management, that's particularly interesting, where you're likely interested in impacts in a particular area or set of areas. So that might be a very powerful capability for the community. So maybe to move on, so one of the components of this pilot that we were interested in testing was with DGGS was to see if it could act as a common operating picture, which in emergency management is this idea of having a kind of a single pane of glass, if you will, that allows you to access all the information that you need to support an emergency management operation. So I'd be curious to have the perspectives from the participants on your thoughts on how DGGS functioned in this within this idea of a common operating picture. So did it work well? What needs to improve that kind of thing? Lucio.
Yes, here I am. I think I feel a little bit on the focus now. Yes, I was going to answer before, but you are right. I think the best place where DGGS can work with AI and give benefit to each other from the application of each other is exactly in the COP area. Common operating picture means transferring from one user to another, from a server to another, or to a client, information, a scenario that include different level of information with different quality, with different things inside, so with the security and all the rest. So at the real end, there you can take benefit of DGGS because you can really precisely identify the volume, in this case of the flooding of the area to be defined, of the area or just the area to be under investigation or during the emergency, and filter the other way around the artificial intelligence alarm results on the document, all the information around the proper event. Imagine you are doing a flooding simulation, so we have answered from the algorithm. For what we have seen, artificial intelligence results are seen like a collateral data, but in any case, you can weight this data. You can stream the information in a certain way together with the geospatial precision of the DGGS, so you are able to give to the user a sort of well-packaged common operating picture with information that a human can always evaluate, but with certain confidence about the results they are there. Not only this helps also in querying better all the algorithm and all the services you are passing to another, so the common operating picture can be an orchestrator that define possibility to access or not certain services to be retrieved to the final user or the people that is receiving this COP. My humble point of view.
No, thank you, Lucio. Yeah, any other thoughts from anyone else on the common operating picture concept? Okay. If not, or wait, sorry, go ahead, Dean.
Yeah, I think to Lucio's comment, so I think there is a lot of potential using this kind of the approach that Lucio outlined in for like an OWS context kind of description and all of the sort of accessibility and provenance and trust information. I think one of the challenges is applying this specifically to a specific domain such as disaster impact or flood risk. I think maybe what's missing here, while what we've and Lucio knows the COP stuff much better than me, but my general impression is that DGGS provides the geospatial context. We can have a specific zone and then, look at subzones and hand that information around. There's lots of, from sort of an OWS context perspective, there's the concept of metadata around, okay, which data sets are, having links to data sets, etc., of what the location of those data sets are and permissions around them. But I think what might be missing is maybe a metadata description specific to disasters. So if an AI is searching for flood risk data for looking at, let's say, the potential for flooding in spring, next month, let's say in May this year, what data sets should it query? And then once it has those and starts asking questions via DGGS or via other APIs, how do you accumulate risk across different domains? So let's say you want cumulative risk, not just due to flood, but let's say flood impacts transportation impacts economics. So you're kind of going across very different domains. So I think the common operating picture needs to be, I think more work needs to be done to define what COP means for a specific context like disasters, and which, like, specifically different risk indexes that where if you're querying one server and get a risk index back, you can apply that risk index, a cumulative weighted risk index between multiple queries, and then somehow sum that risk, have a sense of accumulated risk. And then you also have this idea even of certainty. So the results that we're producing, what's the level of certainty of that result? What's the horizontal resolution, temporal resolution, and probabilistic certainty? So these are some of the things that I think, from a COP perspective, we, at least I don't have a solid understanding of how we can sort of accumulate information between different data sources, APIs, in order to come up with cumulative effects.
Okay. Oh, thanks, Dean. I think Lucio wants to respond.
Yes, thank you, Dean. Exactly, that was one of the items in the second part of the slide I presented yesterday. One slide I added, but it was exactly dealing with the weight of the result, trying to define how much this information is good, but also is dealing with what I wrote there about the dynamic creation of ontologies. And if you use properly DGGS to define small areas or areas in a certain way that are good for the specific phenomenon that you are dealing, emergency or whatever, then you are able to create this set of information, very specific, and extract automatically out of this data dictionary, vocabulary, and then ontologies that you can directly display on the interface. At this moment, the user is more comfortable about this, the information he receives, because she receives, because it's not spare. This information is quite well conceived, specific for the item. Dean, I was doing this with your software well before starting this adventure alone. So that's something exactly what people want, and it's true. The information of the artificial intelligence depends strongly on the data they use. That's why I'm suggesting small local language model to use specific information. This requires some other parameter, but it requires a lot of discussion, and the definition of the revision of the OWS context, that is 2007, I think is mandatory in this sense inside of GC, because it's something that is due for all the technologies and all the new things coming, standards coming up in these days.
Okay, thank you, Lucio. And Lucas.
Yeah, I will be super quick, just to add to what Dean and Lucio mentioned, and I posted here on chat. As it seems, we may have a great opportunity for, let's say, on-the-fly uncertainty analysis. And that's a great added value, to be quite honest. You may have an analysis or querying for data at a resolution 5, but having the uncertainty levels at a resolution level of 6, 7, 8, and 9. And let's say you may have integrated results and outcomes, whether it's related to flood risk or other natural disasters.
Okay, excellent. No,
Thanks.
thanks, Lucas. Yeah, thanks everyone. So I think we'll thanks everyone for your comments on this particular discussion. So I think we'll move on to the next one, which I think is on DGGS more specifically. So I'll pass the floor back to Sina.
Thank you, Ryan. I think we are at the half of this presentation. I mean, this session. Let's take a very, very short break, like a 5 minute, and come back and start a discussion for DGGS and then the AI. Thank you again, and I am looking forward to the rest of this discussion. Very nice. Thank you. Okay, let's start the second panel discussion. So just to start this discussion, I just want to have a very, very brief intro to our discussion. Uh, I want to say first that as you might have noticed, DGGS is a digital reference for Earth, and it's really one vocabulary for all of our data. That's the general idea behind the DGGS. So this cells give us stable and unique IDs. So Earth observation models, raster data, vector data, statistic data, they're all line up without gymnastics. Like you don't need to change much. You can easily interoperate. Uh, well, the question is, if you are conformant, then you can do that. So open standards keep us interoperable across different grids and vendors. So it is important for DGGS to follow this path. Equal area and hierarchy support basically fair aggregation and explainable decisions. So you can repeat basically the same results easier using the DGGS. OGC just recently released the DGGS API, which is critical for developers because it simplifies basically the use. You don't need to go through the documentation of a DGGS core standard to use it. And now you can easily use the libraries. So we have updated and created multiple libraries supporting different programming languages, as you have seen from the presentations from yesterday and today. OGC API DGGS is actually that plumbing. It's the tool that can discover and retrieve the same way, basically. And interoperability will let us avoid the basically grid lock-in. And it basically you can change from one grid to another grid very easy if you are conformant with this standards. And basically that will protect the public investments. So you do this DGGS once and you don't need to do it again and again and again. This is how we move from find the data to basically answer the questions. And AI really needs a structure, and DGGS basically turns maps into that machine-readable facts of ingestion for the AI. For floods, as we have already discussed, that means cells with people, with roads and risks, and they're ready to act, they're ready for action. Let's right now basically focus on the discovery of data and basically the summaries, uncertainty, and the registry. So let's make the DGGS become ubiquitous and universal. Okay, I would like to start the discussion basically with this question that what did actually cross DGGS translation actually cost in fidelity and latency across different types of DGGS like H3, HailPix, IGO7? That came out as one of the most important outcomes of the DGGS standards. So I think it's a fair question to ask. And maybe if the participant would like to answer, uh, please provide your answers. I put the question in the chat. Okay, Johan.
Yes, I can give a few answers in terms of the performance and reliability of each DGRS, because we made a few benchmark on it. And well, maybe if I could share my screen, it will be better.
For sure.
going to show just one page from the wiki we've made for this pilot. Okay, do you see it?
Yes.
Okay, I'm going to zoom in a little so everyone can see. So as part of this pilot, we made a small benchmark here, and we actually compared the different DGGRS in terms of performances. So we have actually seen that when you query one DGRS, you don't always have the same amount of zones which are returned. So we had to actually made a common denominator, which is a zone count, to actually compare each DGRS among them. So what we have seen is actually performances depends greatly on the backend library we are using. So from what we have seen so far, the H3 library is actually the slowest. But if you use libraries like S2, ILPix, or DGGAL, you will have quite stable performances. So on this side, you can choose whatever one you want. Choose the one with the kind of cells you like, squares, hexagons, and so on. And when it comes down to how should we say, efficiency, we can say that DGGRS are not as fast as traditional grid coverages, but they are quite fast enough for normal visualization. So I'm going to show you another one. Just 1 second. So can you see it?
Yes.
Yes. Okay. So this is just a small DGGRS client we developed here for this pilot, and where we can actually zoom in and see how fast the different DGGRS are behaving. So here we are on ISIA 3H, but we have also ILPix, R-ILPix. So you can see it's still very fluent, and the server is not on my machine, it's somewhere else in France. So the results are quite correct. We also have, just 1 second, Gnosis. So we have one from DGGAL here, where we can see the cells with different sizes. And for a daily use, I guess it's actually totally fast enough to render information well, quite streamlessly, I guess, without any major locks or slowdown. So of course it's the first version, so there will be more improvements in performances in the coming years from all library which exist. And I guess the performance side, DGGRS are going to be, well, fair enough for everyday use and processing operations. Any questions on this? If you want me to show something special, or I can stop sharing here.
I'm just curious what the resolution is at the lowest level in terms of, let's say, kilometers.
You want to see the resolution of the data I have here?
Yeah, like from
okay, let's go and see.
What's the highest res at the lowest zoom level?
Here I'm using a GEPCO dataset, so I guess it's 100 meters, something like this.
Yeah. Okay. Good. Thanks.
Just zooming in, just to see where it starts. Well, it's actually quite accurate here.
That's pretty fast.
Okay. That's it for me.
All right. I don't see any hand raised. Nicola? Yes, please.
Yes, just a quick question. Is that raster-based or a vector-based rendering?
We have both solutions available. The one as was showing with JEPCO was actually vector-based, and the one with the blue marble or true marble, it was raster-based. So the client was actually transforming back the different DGGRS cells back to a raster.
Okay. Okay, thank you. So
And
that's
of
local
course,
rendering.
It's local rendering, yes. And on the server side, the data is stored in geo package, and it's transformed on the fly on every request.
Okay, thank you.
Hey, I see a comment from Jim. It says that Sina started. Jim, do you want to unmute yourself and maybe ask that question or comment?
I will try. I might be somewhat challenged in terms of the audio. Can you hear me okay?
Yes, we can hear you perfectly well.
Amazing. All right. Yeah, so Sina, you started the session with an overview of DGGS and its advantages relative to other geo representations. We've been, DGGS has been around for a little while, but there's been a lot of other traditional methods that people have been using for a long time. And to me, the real interesting question is, how much better is DGGS than those, and for what topics, for what tasks? And I wonder if there's been the talk just now was comparing different implementations of DGGS, which is dynamite. Do we have something similar in our pockets or in the past, or do we have to do this in the future of comparing DGGS as a representation against other representations and saying, oh, it's better here for this, but it's worse here for that? There's always some cost and benefit, and I'm not sure I've seen that, or maybe I've just missed some of that.
Johan?
I guess if you use a classic coordinate reference system, if you make a special one just for the area where you're working, of course, it's going to be better than any DGGRS, which is global to all the Earth. But what is very interesting is you can use the same DGGRS all over the globe without having to think about the transformation or the loss of precision at different places. So it's actually the same accuracy everywhere. So that's what's very interesting. And we are talking about the Earth, but for other planets, this system is very interesting because we don't have really a coordinate reference system for, I don't know, the Moon, Mars, or asteroids and stuff like that. So having one system which is, which works whatever's the area is quite great on other planets too. So, it's just not thinking just about the Earth, but everything else.
Michael?
Yeah, thank you. I'm trying to answer Jim's question also, and I agree with what Johan said. I just want to maybe highlight this one big aspect for me that makes DGGS stand out. One is that it's global, right, and that it's hierarchical. But it's the ability to have this common reference system to integrate all sorts of data sets, and having these sort of predefined areas makes it so compelling to me. When you deal with satellite images, you can see each image sort of as a local grid system, right? And they don't really match until you resample them into a grid system that then gives you pixel on top of pixel, which is then your unit of analysis maybe. So if you want something or look for something that lets you integrate various sources, imagery, vector, whatever, you can see these little containers, these zones, as your spatial units of analysis. And they're also consistent. This grid system is deterministic. It is predefined, right? And you just swap out the data, the grid stays the same. And if the structure of the data stays the same, your algorithms also stay the same. And that, to me, is the compelling argument for DGGS. I hope that helps a little bit as an answer.
Yeah, if I might, yeah, that does help. And one of the things from my point of view is those all sound really good. There's a sense of there's a pre-processing step. Let's first pre-process things into DGGS. What I'm used to is taking some imagery and maps, whatever, and saying, okay, we got to do georegistration, and now we might do resampling. And so it would be interesting to see sort of some contests or some real analytics where you have people who are dedicated to non-GGS solutions, competing with DGGS solutions, so we can really unravel, well, what are the costs, what are the benefits? If georegistration and resampling are dirt cheap, then that payoff isn't the same as it was. You mentioned about the algorithm unification. That's then becomes important. Anyway, so I'm just hoping for more along this line of justification from DGGS.
Thank you, Jim, for the very, very interesting question. Yes, I see. Michael, are you still, your hand is raised? Do you want to answer or want to comment?
Yeah, maybe a comment to Jim's last comment then. Yeah, is resampling really so dirt cheap? That would be one of the questions I could ask. If you would ask ESA maybe and ask them to resample their entire archive into a grid system, maybe they would do it, maybe not. So yes, this resampling is really what was discussed in this DGGS community for quite many years already. Like the idea was then always to resample once, right? So everything gets resampled into a grid system, and then you're working on this common basis. There are even ideas floating around to say, like, okay, you can also design a satellite sensor to acquire the data exactly in these zones right from the start, and then it's in that grid system that may be used from all sorts of sensors, and you don't have to worry about this sensor has that resolution. No, everything would align to this resampled or this predefined grid system to a DGGS right from the start. And I think it could be that it moves in that direction in the future. Getting the community or more users to do benchmarks is definitely an interesting bit. I, however, see that the advantages of DGGS come the more data is in there. So it's kind of a catch-22, right? You need to have that scale to really show the benefits. If you're staying at a somewhat local analysis like this flood analysis here, then it may be not showing all these advantages of a global grid system, which is in the name, right? So yeah, I would also be curious to see more of this benchmarking and head-to-head analytics with, let's say, existing systems. Thank you.
Sorry, if I can maybe just make another little quick comment. Yeah, DGGS, these arguments sound really good, and you're seeing some really good things that you've been doing. I don't by any means suggest that resampling and georegistration really are dirt cheap. It's just that those would be the factors that would help us determine, hey, you don't have to do this anymore. You've done it as a precursor step in DGGS itself. That would be very interesting to quantify.
Yeah, that's definitely would be an interesting use case for maybe another pilot. But that should be done on the data side, I think, because it's going to be really heavy. Dean, do you want to comment?
Yeah, sure. Just to jump in, I really like that question, Jim, and that's something that we could probably explore maybe more in future pilots, because I don't think we did a lot of benchmarking, let's say, between accessing data via DGGS versus just accessing data directly via the source raster or data cube. So that would be an idea for sure for future testing. But I did want to kind of reference what Francis from CRIM mentioned earlier today. I really like how they took GeoParquet and then so they have basically GeoParquet as part of the backend stack. So in some cases, it's not either or. So you could put everything into GGGS, or at the bottom level, you could have that GGGS zone linked to a high-res cloud-optimized GeoTIFF or ZAR file. And so then you basically can use GGGS as an interaction layer on top of your raster data. And so, yeah, you'd have to do a bit of pre-processing. But let's say the source data was just cloud native to begin with. Well, you wouldn't have to pre-crunch that at all. So once you've got your data in ZAR or COG, you could have a DGGS on top of it that simply has reference coordinates, X, Y, Z, T ranges into that source cloud native data, but it's presented in a way that it can be very quickly aggregated with other types of data by zone ID. And so that would basically allow AI to interact with that in a way that if you just have an arbitrary raster data set or data cube, how's AI going to interact with it? Like it's not going to necessarily know what's where. And so GGS gives you that geospatial temporal context on top of your source data. And so if you use it almost like an indexing system into your source data, you could still at any zone level have a link which would give you the source data associated with that zone. Just a thought.
Nicola?
Yes, just wanted to add a quick comment regarding resampling, and because there is always kind of translation at some point because of the legacy data sources we are using. If we're working with Sentinel-2 images, so we have to be very careful when we translate from one raster grid to DGGS grid in order not to lose any quality or any information, because DGGS grid are not aligned with the source data set. So we have fixed, let's say, resolution, or should I say refinement levels. And depending on the way you translate the information, you can lose information. That's a point we should be very careful. So we made some work and some benchmarking on Sentinel-2 image at full resolution, and we basically took the original image, the original band to DGGS grid, and then went back to the original one, the original grid. And so we proved that we can avoid losing geometric or radiometric information, except a small smooth in the image. But that's some point I wanted to note.
Thank you, Nicola. All right, let's change the question. So the second question I want to pose is that about the consumability of the DGGS. So how can we make DGGS more easily consumable by non-DGGS aware clients? So is this best handled by mediating services that translate DGGS into data streams, or basically that into data stream more easily consumable by light clients like GeoJSON, HTML, GeoRSS, or should the DGGS standard be extended to allow for direct interaction with light geo clients? And that is a big question. Should the DGGS standard actually be extended. Jerome, please.
Yes, so I think that we can handle this from a few different perspectives. So one solution is the endpoint that Johan and Nicola proposed during the test bed, which I suggested we kind of reconcile with the existing zone query endpoint. So that's kind of making kind of the use case that I think most clients explored, where you have a question and you basically what you want is you want a list of zones, but you don't know which ones. So you want these zones back, and you also want the data values that come with it, right? So some summary statistics for each zone. So it stays quite simple. You have a query and you want a combination of zone and data values to come back. So that's one way. And the other way, I think, is just that realize that the OGC API DGGS is just one data access mechanism, part of the OGC API family, and there's already several other OGC API. And you can still have all the many benefits of the DGGS by the server having this internally, but maybe it's not necessary that if the client is not aware of DGGS, maybe it's enough that the server is leveraging DGGS in the backend, and you can talk feature collections or coverages, other things that your existing client are already good at, right? So you're still benefiting from the multi-scale approach, because that you will get fast responses, right? And the server can do this kind of data integration between different data sets, but the response that you get back can be something more traditional that your client can readily use. So that's kind of the chameleon approach, as Matt always calls it. So I think that's the second way that we can handle this, is use the other tools if the client is not necessarily DGGS aware.
Thank you, Jerome. Any other comments? I don't see anything in the chat. Dean, yes.
Yeah, I think maybe one. So right now, currently in the standard, I think you can request data back as GeoJSON. So maybe the middle ground is perhaps we have clients that can talk to DGGS in terms of making a. Well, I'm just trying to thinking out loud here. They might have an area request, and then they get back zone IDs, and then try to get the data for those zones. I'm just trying to think. Right now, you can ask DGS for the data back as GeoJSON. So maybe there are other formats that could be supported. But I do admit with what Jerome was saying, that when you get too far down the path of returning things like features, then it looks a bit like a feature service. But you do, I guess the benefit of DGGS API handling it is then, like an AI client would only have one place to go to. But there is also this idea of, right now, I think DGGS is really only set up to query one layer at a time. So would it make sense? I think the other concept that's not yet in the standard is how can you have a general query that might be split up into multiple DGS layer queries that then get summed together and returned as a DGGS response. So like DGGS orchestration. So that's another aspect of this that to me is a bit fuzzy. How would you query multiple layers at once and then do some analytics on the server side? So this does relate to a slightly different question about where does the analytics happen. So if you do get more of the analytics happening on the server side, that would support lighter clients. If you're expecting the client to do all the analytics, it has to be very sophisticated, understand the whole gridding system, and know how to do the algebra across them. So do we have this idea of a mediating DGS service that can take a query, distribute it across multiple DGSs, and compose a response and then send it back? So yeah, asking more questions than I'm answering.
Jerome?
Yeah, so to go in the direction that Dean is leading us, I think that's really that's what the DGGS API was primarily intended for, I think, is to kind of be to help multiple servers resolve queries together close to the data. Because like I said, if you can essentially encode your old query, for example, in SQL2, and if we get into the cross-collection queries, and we can do some pretty advanced queries, and in the end, what you have is a simple answer, and you don't really care how that answer comes back, and that answer can only be so much data that you can see, right? So if it has to be, let's say, something you can see on your screen, so there's kind of an inverse proportion between the resolution of the data and the spatial extent of the data, right? Because it's what you can actually look at on your screen. Because if you zoom, then or you pan, then you can send out another request that will then produce for that other extent. So based on that thing, if you can express the whole thing, that the servers, potentially plural, will resolve the whole query, then what it can send you back can be a more traditional format, like a GeoJSON or a GeoTIFF, for example. That is the final answer to the query. But the very interesting use case of the DGGS API is really to bring the questions close to the data and to kind of have multiple servers where being able to integrate data that sits in different places and quickly come to the answer to the query, right? So that's where using zones and exchanging zones of interest and progressively refining, like Michael mentioned earlier, if you detect a signal of interest, then you might dig in further, more precise, more the deeper resolution to kind of more to inspect closer the data, right? So that's where the DGGS API is really what it's intended for. So really do this progressive refinement and cross-server distributed queries. But we only really touch the surface of this in this pilot, and that's really the thing. And I think several participants mentioned cross-collection queries as something of interest for next initiative.
Or is the standard currently support cross, like, can you compose a query for multiple collections at once in
theory you can, because
okay.
what you have is you have the SQL2, which is very flexible and extensible to the extent that I think it's actually Turing complete if you consider adding new functions. So SQL2 is very powerful, and if you have this concept of queryable, and also the DGGS API is not even tied to a particular resource, so it's not really tied to an OGC API data set or to a collection. It could be to anything. But let's say if you have the data set level query, for example, it can potentially use queryables from different collections. And we didn't really like standardize on a specific way how you can identify data from different collections. That we threw a few ideas around on how to do this, like the joint collections query parameter. So there's not like one standard way to do it, but on one DGGS API, what you can have is a sortables schema that lists the queryables available, and basically those can come from different collections, right? But now if we start going to basically if we want the server to act as a client and let it join collections from a remote service that is not on the same a collection from another service, that's kind of where we didn't really go all the way to specify this. But the idea with the joint collections is you could enter a full URI to another OGC API service collection, and then essentially the server can act as a client, and the whole idea is to try to optimize, and then we get into like the query orchestrator, all these kind of things, right? How to best distribute the things so you do the most computation close to the data, and you do the lazy evaluation, and you do the progressive refinement, all these things that can get pretty complicated, but it's got a lot of power in really optimizing how we do these queries efficiently. So I think all the tools are there, but we need some experimentation to really focus on these cross collection and server acting as a client, which we didn't really get into in the pilot.
Thank you, Jerome. Michael, we have to finish this very fast. So if you have a comment very, very fast, let's have it and then move to the next panel.
Thank you, Sina. Just very quickly, a server as a client, and I just want to pile on to what Jerome said. I think this cross-collection queries will be super beneficial. I'm not so sure if they will be beneficial if the client is a browser and that you just get so much data there that you want to do all this analysis in the browser. But if the server is a client and we just put it in between the OGC API processes and do the processing there and then just deliver a result to a visualization like a browser app or something like this. I think combining the processes and the DGGS API together with the ability to query across collections, that will be really, really cool. And that's all I wanted to say. Thanks.
Thank you, Michael. Okay, I guess this discussion gonna stay open, and it's right to be stayed open, I guess. All right, Stelios, do you want to start the next panel?
Yeah, thank you, Sina. I'll try to put some context with a couple of slides. Let me share my screen. Can you see my screen?
Yes. Yes.
Okay. I did some change and I'm not seeing what you see. Okay, I'll try to work on a few terms that we'll discuss about, and I think they are important on our, let's say, discussion for AI and DGGS. One term is about geospatial reasoning, and I took a source from Cartos, that is the ability of an AI system to understand a complex spatial problem independently, devise a multi-step analytical plan, execute it, and interpret the results to provide an actionable solution. It goes a bit more to the agent world. And if we see to other key insights could be to provide some advanced problem solving, okay, make some data integration, have something beyond just simple visualization on a map. It is close to what we call geospatial foundation models, and somehow to provide actionable outcomes. One thing that at least throughout the pilot we found as necessary is to guardrail in geospatial world the AI, and here are some methods that we could do it through data validation, checks on what the system it gets in or out, static guardrailing, such using reference datasets to establish logical constraints, or dynamic guardrailing, compare predictions against trusted external models to identify anomalies. Another thing that we also discuss in a lot in the, not a lot, but we discuss it in the website, and we will have it also in the AR. It's about the AI orchestration. Can be referred how to manage and coordinate AI agents, primarily using the model context protocol. At least this is what we have now. We may in the future have more protocols on that. To connect with external data, tools, and systems, allowing complex tasks to be broken down to smaller, manageable steps, ensuring efficient workflows, data flow, and reliable business outcomes. And the key components here are the LLM by itself, the context, which is all the information that gets into the model, data and documents, the MCP protocol, which comprises by the host, the client, and the server we get the data, the host that runs the protocol, and the orchestrator. Either it's an in-house software or a LangChain system or something else. And discussions that arise during the last pilot meetings was referring to discriminative versus generative AI and where we should focus upon. I understand that discriminative is more to what ML or DL is providing, and okay, Gen AI, And I think we need both. Discriminative AI identifies current conditions like classifying road segments as safe or hazardous, while generative AI can synthesize these findings by producing evacuation plans based on simulated scenarios. So by combining this approach, the system can move from simply identifying what is to independently creating a solution for what to do. That is the context I thought of having in this discussion, and I'll pass to the first question, which is mainly the question provided by Jim, and we thank Jim for that. It appears that there was an intuition that DGS would be particularly well suited to AI systems. Did initial intuitions hold up where they found to be true, or perhaps the experience in the initiative suggested that they could be made true? They are true, or they can be made true. Looking for volunteers to initiate the discussion. Jim, do you want to comment on your question?
Well, only that it was actually a sincere question. The idea of again, I've done geospatial reasoning for a long time, automated reasoning for a long time, but not in DGGS. So I tend to think, well, okay, so what is the payoff? And I'd really like to have that sort of quantified, or at least more anecdotes about it.
Jerome.
Yeah, so I'm hoping someone else who actually work on the AI aspect in the pilot will comment, but since no volunteers, so I just want to repeat my suggestion earlier. It's not what we did in the pilot, but I really think that vision transformers is, and that's kind of a light bulb that went on this morning. I think the subzone concept would really be great to kind of be a general way to do the vision transformer approach, kind of get the attention of the different subzones talking to each other so that the LLM can see what is in the parent tile and do this and aggregate that to the cursor level, or the other way around. You start course and then you keep refining. But for this, we would need to train the actual model would need to be trained in the context of a specific DGGRS. So you would need to train a different DGGRS for each one. But I really think that would be a really powerful thing to explore in a future pilot. So yeah. Dean has a comment, I think.
Thank you.
Yeah, again, I would sort of defer to the folks that actually had the AI clients. So, my impression was working with TerraFrame that the DGGS did definitely add value, because it kind of kicked off the processing in terms of figuring out where the initial high flood risk areas were, and then they could feed that into their spatial knowledge graph and then figure out what the downstream effects were. So, but in terms of, that's still fairly prescriptive. The orchestration is kind of prescribed in that case. We have sort of this whole predefined chain of dependencies of looking for flood risk first, and then what are the downstream effects. Whereas allowing an AI to kind of more freeform explore, let's say if you have a natural language question about what are the natural hazards in this region, then to Jerome's idea of this, vision transformers of drilling into different zones and then using those zone IDs to query across multiple domain DGS services and kind of scout around for risk. That, yeah, I'm a bit more fuzzy. I think that's all doable. That's kind of the potential, but I think that level of sort of freeform orchestration, we didn't really have as much time to get into. And I think also the idea of an SLM, so that's in between LLM and just kind of procedural. So a simple language model or a what you were, I can't remember the term for, not a general, but a simpler, more focused domain-specific model could have a finite.
Geospatial foundation model.
Well, I wasn't thinking so much geospatial foundation model. It's
domain.
Can't remember the right term. Yeah, like a domain-specific model, or you can create models that you can train for a specific domain, and then that model would be aware of, let's say, a few dozen DGGS services that are relevant, but would still be free to sort of game through those, or you could do training on them for different disaster scenarios. So I think that's sort of an area worth exploring.
So if I understand, the answer is that it holds up. They are true, but not exactly. But they can also make more true. If I answer the question.
Yeah, I think we made a good start, but
yeah,
certainly, yeah, it could be made more true with more development.
Move on.
Hi, this is Nathan. My hand raising function is not working on my Teams client. So later I'm going to jump off and then jump back on. Otherwise I would have raised my hand. Yeah, so I think regarding your question, when it comes to AI systems, I mean, we have been exploring these large language models and have, I think, experienced some of the limitations there from a findability standpoint. There's no question that there's great value here. But when it comes to the field of geospatial foundation models, there are models that exist that are not text-based, and so I don't fully understand what that means, but that is something I am looking into, because I think we need a different paradigm if we're going to have a model reason about the actual contents within these DGGS zones, and especially when you're combining values from different sources, from different domains. I think there's just a lot of research that needs to happen there.
Yeah, I would add to that maybe the models are not only about data, but also about the actual logic that needs the specific domain or the phenomenon to handle upon. So it's not only about having tokenization about the specific data sets that may be needed, but also knowledge about the physics of the field domain that we need to take care of. All right, I'll go to the next question. What kind of AI were we most interested in, worried about, or focused on? Generative AI, foundation, neural net models, especially language-based systems with relatively unconstrained prompts as inputs, or discriminative neural net models trained to recognize some class of events of interest by generalizing from a set of examples of the events, or more crisply defined non- and natural net systems, just as knowledge graphs, ontology-based systems, etc. Jim, do you want to comment on this question? Or someone else?
Yes, I think you kind of sort of presented this idea that we kind of need the discriminative and the generative AI both used.
Yeah, I touched upon the last slide. I think that I think we need both. Well, it depends on the context of where we want to apply the AI system, but there is some good sense that we may need both. The discriminative to understand what is the current situation, and the generative in order to to provide us some insights that we could not understand or could not find from the past, and we need to find solutions that are on a phenomenon that is in front of us. At least this might
correct me if I'm wrong. I think we did the third option, which is more crisply defined, basically knowledge graph or ontology-based systems, because we kind of controlled the questions. That was my take on this question.
Yeah, I think we touched upon the third. I think in our system we touched about the second, and at the end we try to touch on the first one. But okay, that is something that we may need to do in the future a lot more. I see some hands raised. First is Jerome, please.
Sorry for repeating myself, but I think we do need to add to the list. It's kind of going in the first category, but specifically, I think vision transformers, and also Michael mentioned GNN. I think it's graph neural nets. So I think we should specifically consider this for future work.
Mm-hmm. And Dean.
Yeah, so it's kind of two different levels of the question. So in terms of what we actually did, I think I agree that using knowledge graphs and stuff. So that's the more crisp models. That's obviously something we did in this pilot. We still did use the Gen AI LLM stuff, as Justin and others pointed out, for the chat bots, for the chat front end. So to convert natural language into queries for DGGS or for knowledge graph. So at that level, we used LLM. I think one thing we should add to the list is SLM, because my understanding of SLM, the simple language models. So I think we don't just need a general geographic models, but we also for the domain knowledge, an SLM can be configured specifically for dealing with natural hazards, and so it would have resources and data, and perhaps some of those kind of ontologies and dependencies, if you're looking for flood information, you need this type of information. So you can pre-configure an SLM with information so that it has a bit more context to that specialized area. So that's something we really didn't look at all in this context with the SLMs. And, again, in general with OGC, we're pretty good at standards around integrating data, integrating schema, integrating services. We're less good at defining standards around domains. So an exception to that would be sort of the muddy effort, because in that effort, we're dealing with sort of a digital twin of the underground utilities. And so there's a lot of domain-specific stuff around utilities in muddy. But outside of that, we haven't really articulated either the ontologies, schemas, or dependencies associated with, let's say, natural hazards or other types of like public safety risks.
All right, Lucio.
Yes, confirming what. Thank you, Dean, for what you just said. SLLM is a good asset. This, to my understanding and to my experience, the extraction of information out of imagery, or when you are sketching information, creating a vector database for roads or for any other infrastructure, you have a certain guidelines that you should apply to extract this information. So you are increasing the quality of the data derived out of this extraction mechanism. Using this and applying the same extraction guidelines for the results somehow of the artificial intelligence, also small dedicated local language model, and not using the 8 billion, 10 billion term of Oyama or any other large language model, you obtain a more trustable results with a certain degree of scoring of the information and so on. But if we are able at OGC to refine this and to find the rules how to do this in a proper way, as Dean said, for specific argument, for specific phenomenon or context, we are able to increase the trustness of the people on the geospatial information fused also with artificial intelligence data. Keeping in mind that we need to have the provenance of this information quite clear, authenticity of the information, and so on and so forth. So that's it.
Thank you, Lucio. The next question is, what would DGGS seem to offer the specific kind of AI systems we focused on? Someone wants to comment on that? Is the question clear? Maybe not.
Not much.
Not much. I'll move to the next one. Gen AI systems seem to use a semantics defined by its associations in vast, high-dimensional, semi-continuous vector spaces. The semantics of DGGS, on the other hand, depends on crisp representation in an explicit space of iconic representation. Did this represent a problem, an advantage, an opportunity? What do you think? I think we are discussing again about the glue between Gen AI and DGS, but
yeah, this is Jim. I apologize for dropping away. I had serious microphone issues going on. Hopefully, I wasn't causing echoes over there.
No.
Or anything. Yeah, it sounded to me like this was being addressed earlier when we were talking about the my parlance, discriminative versus Gen AI, and that there's a lot to do still in Gen AI. That's a much more challenging arena, and it seems to be taking the world by storm. So it seems important for us to get our this technology wrapped around that.
Yeah. Well, in our discussion, I think we need to see our world on the edge of generative AI and discriminative AI. So somehow both have advantages, and depending the context of the use case, we need to touch both worlds. Generative AI can produce new information, new context, but we still need some knowledge on what happened and analyze the past. I see more hands coming up. I think first is Jerome.
Yeah, so I just again just mentioning that. So when we talk about Gen AI, I guess in the context of what we did in the pilot, what we were generating was mostly text, and I guess in some cases some maps. And then we talk about discrimination, but like the vision aspect, I think is really a key thing that the future pilot we should focus on a bit more, because that's kind of the actual analysis part. So I'm curious with what you guys, kind of throwing another question here. How does this fit within what you guys were doing in the client? Like maybe we need more of that vision aspect in order to really answer the query question.
Right. Nathan.
Yeah, I was wondering, has anyone come across a paper or an article that talks about what representing quantized values in DGGS zones in a vector database, what that means? Because you certainly can do it, but I just don't understand how the vector space will help us with determining similarity. Because when it comes to text, concepts that have similar meaning are represented very close to each other within a vector space. But when it comes to the location of the cells, the granularity, the domain, and the values, to what extent can you represent? Of course, you can represent that in a vector database, but it's not clear to me what that means. And if anyone has come across anything that speaks to that, I would be very interested in reading that.
I think Michael before talked about tokenization of geospatial information, and this may be different from text vectorization. I don't know, Michael, do you want to comment on that more?
Yeah, thank you. I'm skipping the line here. Nathan, yeah. So I don't have a resource that you could read on this. The way I always saw it is like, okay, the grid system itself is, for me, it's a graph, right? You know the neighbors, you know the hierarchy, you know the children and the parents. So this kind of, for me, is very well suited for a graph neural network, right? And then the vector is essentially the values that you accumulate per zone. So if you have climate data there, if you have population data there, all this information is associated with zone ID, and that to me becomes a vector, right? And then you can do similarity analysis and figure out, okay, where are zones that have sort of a similar profile? I always named these things then a spatial token or a digital fingerprint. Each of these zone IDs has sort of a digital fingerprint, and you can match, and yeah, well, fingerprint would be unique, right? But you could find similar fingerprints in terms of the data context that this particular zone has. Again, sorry, I don't have a specific resource for that, but that's how I sort of conceptualize it.
Okay, so then the similarity would be the granularity, the zone ID or similar zone IDs. That's the spatial similarity. And then the domain would also be another aspect of similarity. If I'm understanding correctly.
The similarity across the values at that location. So the similarity of population density, temperature, height over zero, and whatever other value you put there. I see, and that was my earlier comment, DGGS really, to me, shows its benefits when it's at scale. If you're working with just 1 or 2 data sets, it's not really worth it to go to a DGGS. Once you really integrate 10 plus 100, 400 data sets, or that's what I had in my paper, if you go to a lot more, you can describe that one zone with all these properties. And then what becomes more relevant, I think, is then you need the ontology, right? What does that value here, that specific column sort of in my data set mean, and how does it relate to the others to really get a full picture? But the vector to me would be the zone ID as the identifier, and then all the values sort of in the columns that are associated with that zone ID.
Yeah, and all the more useful it would be to have the value description mapped to a formalized ontology, like you said, so we can derive in the vector space semantic meaning. So when I say population in my question, there's in vector space it has an idea of what you mean by that.
Absolutely. This is also, I wrote it in the chat only as a comment. We cannot just throw all the data at the system and let the AI figure it out. We need to tell it an ontology. What does it mean and how does it relate? Yeah. If I talk about population, it may mean something completely different. So all this needs to be defined and part of the algorithm. Yeah.
Lucio, do you want to comment on the ontologies?
Yes, what just the last person, I don't remember this, the name, sorry, said, confirmed. I mean, what we have to do here is to try to decouple, to transform the information, the textual information in vector, in graph, with an ontology, and see if small is better. So at the real end, we are able to chunk all the data in a certain way that all the information is managed by a sort of a graph database where we can finally merge all this information. In this, DGGS is helping, and also the fact that they have to chunk all the information, as I wrote in the chat, in a way that we are able to extract out of this a graph for the information itself. But for this, you need ontology, but because you add each time new information, you can add, if you query, you add also information, you need something more dynamic to have the result properly fitting the purpose.
Thank you. Dean? Dean, we cannot hear you.
Yeah, just going back to the original. Thanks. Going back to the original question. I don't think we had a necessarily that it presented a problem going from Gen I or going from the general to specific, but I'm not sure that we really iterated through that. So what I mean by that is, from the Gen AI, let's say the LLM perspective, you ask a question in terms of, flood risk near Winnipeg, and then we have, based on what I understand how Terraframe's flow works, they have jurisdictional areas. So when you have those named areas, then you get a polygon. And so that's a very kind of prescriptive way of converting from the Gen AI's place name into a vector area, which then can be indexed against and find a bunch of zone IDs. And then from those zone IDs, we can do some queries and figure out downstream effects. But that's kind of a one-way trip when we did it in this pilot. I think the real power would be, once you have those zone IDs, now the LLM or the Gen AI can now make additional queries based on those zone IDs. In order to do that intelligently, like you guys are saying, you need an ontology. You may need to provide the whole DGS spec to the Gen AI. You need the ontology, and I don't know if not understanding exactly how these things are configured, the Gen AI itself might need some experience with DGGS to actually start to be more successful with it. But anyway, over time, you would hope that this would be an iterative process so that these zone IDs just become links to information the way that an address might be a link to information. And then it can accumulate information around those zone IDs and their subzones. So, how much information, how do we end up training the LLMs to do this properly? Or is it going to be easier to train an SLM? That I have no idea. I don't think we really explored that, but I think there's a lot of potential there of having these integrations between CRISP and more general type AI models.
Just to comment on that in our pilot, in our use case, in our agent, we vectorized the standard, the DGS standard, and the libraries of DGGAL. So we gave them as food, to understand. We trained the model, trained in quotes, what is the new standard and what is the library that we tested in our pilot. I understand that the replies that we got from the system after we gave them this information was better than before, but we didn't do a proper testing on that in order to see before RAG information, giving the vectorized information to the model, and after that. But my feeling is that the LLM system behaved better, DGGS aware after having the RAG information. Sorry for the comment, Jerome.
Yes, so yeah, sorry to repeat myself again, but really what I feel is the missing piece. And yes, the LLM can understand the zone IDs to some extent, but I think really what we need to do, and I think this is how the foundational geospatial models are working, is essentially they're doing it with rectilinear, and now we're just generalizing it to other DGGRS. So to answer Nathan's question earlier about how you can make some semantic sense of these vector spaces. So first you have the vector spaces about the actual values, right? So if you're analyzing like an elevation data set, for example, it's kind of making sense of that with the semantics. So you have the semantic aspect of the values, but then you also have like the relative, the relation between the different zones around. So if we focus on training on an ancestral zone and the subzone, and we really focus on this concept of subzones, which is just like a regular like grid in a rectilinear tile, for example, like in a regular image vision. So if we extend this like for hexagon grids, for example, then the system is able to make sense. So it what it does is it analyzes the value. So first you tokenize them to the individual subzones, and then when you train the model, you help it to make sense of what is next to each thing. So each token, which is an individual subzone value, gets imbued with what is around it. So that's what the whole attention is about the big transformer paper, right? It's imbuing each token with the tokens around it. And then what you do with the transformers is you alternate the attention layer with the perceptron layer, and you repeat this a few times, right? So that's kind of how you build this whole neural net for vision. And that's really the approach that I think would really make DGGS shine, especially when we get with the hexagons, where you have like 6 neighbors, more regular neighbors. So I think that would be really, really powerful, and that would be really interesting to test. And this is kind of how you can, so that's the vision aspect. How can the system really make sense of what it sees? And then you can repeat this at progressive level, either drilling down or building, aggregating back up to a coarser level.
I will just I want to add a quick comment to that. The one thing I think, and I saw it in the chat earlier, but I think one aspect of all this that's important, I like this visioning aspect, but in order for the LLMs to understand which data sources are relevant for this visioning, one aspect I think we really haven't explored that much, maybe in future pilots, would be what sort of metadata does a DGGS service need to provide so that ontologies, or for context, is this service worth querying? So you don't want to even bother querying the service down to the zone level if the data is not relevant to that query. So I think we kind of have to have some domain specific metadata for the services that are consistent, maybe standardized by OGC, so that AI's querying for different services don't actually have to drill into the zones to figure out if there's relevant information there. Just a thought.
I felt that we needed also metadata regarding the collections and the cataloging of the data that existed in a server or in multiple servers. So understand that the metadata should be relevant to the ontologies, but also relevant to the cataloging of the data. And I'll wrap up here. I'll read the comment of Jim saying that Jerome, please wrote these ideas about vision transformer and DGGS in the ER. So I would welcome Jerome to add a section on the ER about the great ideas. And I will wrap up this panel, and I will thank all of you for contributing to the discussion, and I will give back the floor to Sina. Thank you.
Thank you, Stelios. And yeah, we are 9 minutes over, so I won't hold you more as much as I like to. This is great discussions. Thank you again for joining today's and yesterday's workshop. I hope you enjoyed it. The recordings will be public. I'll try to figure out a way to make them public, and hopefully you enjoyed it, and we will see you on another events in OGC. Thank you.
Thank you.
Thank you very much.
Thanks, Sina. Thanks, everybody.
Thank you.
Good job, all.
Thank you.
Thanks, everyone.
Bye.